In this video, we will be recapping the product rule. The product rule is when you have a first and second factor that have x's in them. So something that is not a product rule would be like 5 e to the x. 5 times e to the x, there's only one x in there. You would just keep the constant multiple 5 and take the derivative of e to the x to be e to the x. Whereas a product rule has x's times x's. So if you had maybe 5x squared times e to the x, you have x times x. You can call 5x squared the first factor, e to the x the second factor, and apply this product rule, which is the derivative of the first times the original second, plus always for product rule, the derivative of the second times the original first. So we're going to run through this piece by piece. Derivative of that first factor, 5x squared, is 10x times the original second is e to the x. Product has a plus. Now I'm going to take the derivative of the second factor. The derivative of e to the x is e to the x times the original first is 5x squared. And you're welcome to separate these with parentheses. That way it's easier to check over. Did you get all the pieces? Derivative of the first, original second, plus derivative of the second times the original first. It's not wrong without parentheses, but sometimes it's helpful to have them there. So if we apply that again, something that is not a product rule would just be like 7 times ln of x. It's not x's times x's. You just keep the constant multiple 7 when you take the derivative. So keep the 7. Derivative of the natural log of x is always 1 over x. Whereas what is a product rule is if you have x's times x's. So if we just switch it slightly, if we have y equals 7x times the natural log of x. Now we have x times x. 7x times the natural log of x, we'll call 7x the first, ln of x the second, and we'll apply that product rule. So y prime derivative of the first factor, 7x is 7, times the original second is the natural log of x. Product always has a plus. Now the derivative of the second factor, natural log of x is 1 over x, times the original first is 7x. There are things you could do to simplify that, but we can also just leave it as is. Derivative of the first, original second, plus always the derivative of the second times the original first. So continuing with maybe one last product here, if we had x to the fourth minus 13x times 2 to the x plus 8x. So a bigger x times x piece here. I'm going to call this the first factor and this the second factor just based on where they are. I'm going to go ahead and take the derivative of it by following this product rule. Starting with the derivative of the first factor, derivative of x to the fourth is 4x cubed. Derivative of negative 13x is negative 13. There's the derivative of the first. That gets multiplied with the original second. 2 to the x plus 8x. Product has a plus. So we did the derivative of the first, original second, product is plus. Now I'm going to do the derivative of the second factor. Derivative of 2 to the x is ln of 2 times 2 to the x. If you didn't remember that, you can check out my exponential rule recap. Ln of 2 times 2 to the x plus the derivative of 8x is 8. So we did the derivative of the first, original second, plus the derivative of the second. Now we need to multiply it with the original first. X to the fourth minus 13x. So definitely a bigger looking answer, but there's our product rule. Derivative of the first, original second, plus derivative of the second times the original first. Now we know we're done. And we only apply this if we have x's times x's. That's how we know to use a product rule for the derivative.